Now we're going to take a look at how to find the domain of combined functions. Now f plus g, f minus g, and f times g will always have the same domain, and it will be the intersection of their separate domains, whereas the domain of the quotient f divided g will be that previous answer, but also further restricted, so g of x is not equal to 0. So let's take a look at how to do some of these problems. Let's start with this one right here. Find the domain of f of x. Well, you know f of x is a square root, and x minus 2 must be greater than or equal to 0, meaning that x must be greater than or equal to 2. So the domain, I'm going to actually graph this on a number line, we'll use that in a moment later, will be all values greater than or equal to 2. So 2 to infinity using interval notation. Now function g has no denominators and no square roots, so right off the bat we're going to have all real numbers. Now in part C, they're asking us to find the domain of f plus g, f minus g, and f times g. Basically, they're asking us to look at this 2 and above, which was the domain of f, and this all real numbers, which was the domain of g, and find their intersection. Where do they overlap? And the answer is they overlap from 2 to infinity, inclusive of the 2. So that will be the domain of the sum, difference, and quotient. Now for the domain of f divided by g, now I need to make sure that g of x cannot equal 0 because I can't divide by 0. And that means x minus 4 cannot equal 0, and that x cannot equal 4. Now let's take a look at what we have. Previously, we know that the domain of the sum, difference, and product will be from 2 to infinity. Now we're saying everything but 4 is allowed for the quotient. So what is the intersection of these? Well, include the 2, up to but don't include the 4 because that's restricted here, united with 4 to infinity. So I took my previous domain and I further restricted it by taking the value 4 out of it to get the domain of the quotient of these two functions. Let's try this idea again. Find the domain of f. Well, here we know that x cannot equal 4, which I will write in interval notation as negative infinity to 4 united with 4 to infinity. What about the domain of g? Well, x cannot equal negative 2 in this case, so the domain will be negative infinity to negative 2 union negative 2 to infinity. What is the domain of f plus g, f minus g, or f times g? Well, x cannot equal negative 2 or negative 4. Where do those two above intersect? And so that means we will have from negative infinity, that should be a positive 4, negative infinity to negative 2, union negative 2 to 4, union 4 to infinity. So basically everything but negative 2 and 4. I need to now look at the quotient to find the domain of f divided by g. Well, let's think of what would happen if g of x cannot be equal to 0. That means x minus 1 over x plus 2 cannot equal 0. When is a function equal to 0? Well, the function is equal to 0 when the numerator is 0. So now we're saying x cannot equal 1. Now we'll talk about the denominator here in a second, but what we have is now x cannot equal negative 2, 1, or 4, which means our domain of the quotient will be negative infinity to negative 2 united with negative 2 to 1 united with 1 to 4 united with finally from 4 to infinity. Now, why are we not looking out for this value down here? Well, first off, we already know that we've excluded negative 2 right here, and so we don't have to deal with it a second time, but let's pretend that this was a different number like 5. We would not be excluding negative 5, because if you think about it, when you go f divided by g, when you divide by a fraction, you multiply by a reciprocal, and that moves the x plus 5 up to the numerator. And that's why we don't have to consider that there. But it really doesn't become an issue in this problem. Now, how do you find the domain of a composite function? Well, basically you find out what f composite g in this case is going to look like. This is where g gets substituted into f, and f says this is the square root of input minus 3. And the input here is x plus 7. And so this becomes the square root of x plus 4, and we need to make sure then that x plus 4 is greater than or equal to 0, and therefore x must be greater than or equal to negative 4, and the domain of this composite function will be from negative and 4, which we include, up to positive infinity.